Hi, hello, welcome to Homeschool. This is our fourth session of probability. Okay, last class we already have completed up to your 13 problems. We are going to start 14 problem. Before that, I want to show you something. Instead of starting that problem, we are going to see something here. Can you see this? Yes, what are these? These are cards. Before dealing our 14th problem, we should have a little idea about these cards. We have never seen these cards. So here, 4 colored cards you have. 4 shapes, sorry, 2 colors and 4 shapes you have. I think everyone of you know this shape. Heart shape, diamond shape, club shape, spades. Okay. So now I am going to introduce you one set here. Can you see this clearly? So here you can see here king, queen, jack. See, only these 3 cards we can see the faces. So we call them as the face cards. 3 face cards. King, queen, jack. Next 10, 9, 8, 7, 6, 5, 4, 3, 2. 1 not there. Instead of 1, we use ace card. A is none other than the ace card. Okay, same patterns we'll be having in diamonds, in clubs and also in spades. So total how many cards we are having here? Hearts, 13 heart cards, 13 diamond cards, 13 club cards and 13 spades. Okay, so here total how many red colored cards you have? 13 plus 13 it will be 26 cards. Total how many black colored cards we have? 26 cards. Okay, this is the small tiny idea about the cards. So we have ace cards. How many ace cards we have here? 4 ace cards we have. And overall 4 kings, 4 queens, 4 jacks, 4 tens, 4 nines, like this. All 4 cards you will be having. When the question comes under any shape or a color, it differs. Okay, let's start our question. First, we do this problem orally. Okay. One card is drawn from a well-shuffled deck of 52 cards. Find the probability of getting a king of red color. So, let's start the first question. What is the first question here? A king of red color. So, these 2 are red colored cards. How many kings you can see here? 1 here and another here. So, total 2 kings. So, what's your probability? Probability of an event by total all the possible outcomes, in the sense sample spaces. That is 2 by 52 is your answer. Second question, a face card. How many face cards you can see here? 3, 3, 3, 3. Total how many face cards you have here? 12 face cards you have here. So that is 12 by 52 is your answer. A red face card. Red color, how many face cards? 6. 6 by 52. And next 4th one, the jack of hearts. The jack of hearts. In heart symbol, jack they are asking. Jack, how many jacks you have? Only 1. That is 1 by 52. A spade. What do you mean by spade here? What are the spade cards? How many spade cards you have here? 13. 13 by 52 is your answer. Next, probability of getting queen of diamonds. Where are diamonds? These are diamonds. Queen of diamond is only 1. That is your probability is 1 by 52. So, I have done the small tiny example to make you clear of this problem. So, if you know idea of these cards, you can answer any type of question. Suppose I can ask you, how many red colored cards are there? What is the probability of getting red colored cards? That is, you can add these 2. 13 plus 13, it will be 26 by 52. Same manner, black color cards, 26 by 52. What is the probability of getting ace cards? 4 by 52. Probability of getting queen cards? 4 by 52. Like this, any question if they ask, you can answer this way. This is very easy to understand and very easy to answer. So let's see this on board. Okay. The same thing I have done on the board also, same problem. So you can see here with the letter S. S is nothing but sample space. S is equal to set of. I have written all the possible outcomes. In the sense, all the cards, what are all values you are going to have here. Heart shape, diamond shape, clap shape and spades. All you have here. 13, 13, 13, 13. Total how many cards you have? Total number of sample spaces is equal to 52. So let's start the same thing we answered on the board. I already have done some rough work on the board. It makes us too easy to complete the problem. So now, a king of red color. Same question, let's answer here. A king of red color. So let the event question, I have already told you every event question we can choose with the letter A, B, C or E1, E2, E3, E4. However you want you can consider. So let me start my first question with the E1. So number of E1. What is a king of red color? What is my question here? King of red color. So N of E1. N of E1 is equal to king of red color. How many red color kings are there? 2. So let me write it as 2. Probability of this event is equal to total number of event by total number of sample spaces. That is 2 by 52 is your answer. That's it. First sub question is completed. Coming to your second sub question. A face card. How many face cards are there in this? Let's see once again. I think these are all face cards. Total how many face cards you have here? 12 face cards. So N of E2 is equal to 12. So probability of this event P of E2 is equal to N of E2 by N of S. That is 12 by 52 is your answer. Coming to your third sub question. A red face card. Red face card. How many red face cards are there? See here. These are red face cards. 1, 2, 3, 4, 5, 6. So let the event be E3. Number of this event will be 6. Probability of occurring this event is equal to 6 by 52 is your answer. Coming to your next fourth sub question. The Jack of Hearts. The Jack of Hearts. Only this one. So how many you are having in this event? Only 1. So that will be 1. Probability of occurring this event is equal to 1 by 52. And coming to your fifth sub question is spade. How many spade cards you have here? Total 13 spade cards you have. So total number of spade cards is equal to 13. And probability of this event P of E5 is equal to N of E5 by N of S. That is 13 by 52 is your answer. Coming to your sixth sub question. The Queen of Diamonds. Where are diamond cards? Here. Queen of Diamonds. Queen. Only one queen we have in your diamonds. So let the event number be E6. N of E6 is equal to 1. Probability of E6, P of E6 is equal to N of E6 by N of S. That is 1 by 52 is your answer. So with this, we are going to complete our 14th problem. It's very simple. Easy to understand and easy to answer. So coming to your 15th problem. Let me read the 15th problem here. 5 cards. Okay, we are dealing with only 5 cards. The 10, Jack, Queen, King and Ace of Diamonds. Okay, let these cards. How many cards we have here? 5 cards. Let's write here. 10, Jack, Queen, King and Ace card here. So what happened here are all well shuffled with their face downwards. Means closing cards. One card is then picked up at random. Now what are we doing here? I am going to pick one card from this set. So what are all the cards? We write it in the sample space S. So total number of sample spaces N of S is equal to count the cards and say it is 5. Okay, let's start the question here. What's your first question here? What is the probability that the card is queen? What is the probability that the card is queen? How many queens you have in the set? Only one. So here total number of cards 5. So your first event E1 is equal to Q and total number of this cards is equal to 1. Probability of E1, P of E1 is equal to N of E1 by N of S. So 1 by, what are the total number of sample spaces? 5. 1 by 5 is your answer. So this answer is very easy. Coming to your second sub question, it will be tiny little difficult. If the queen is drawn, and put aside, okay, let me pull out the queen here and throw aside. So second sub question, again I am writing the sample space. Can you see here? I have written the sample space without a Q. In our question, Q is taken and thrown aside, means in my next sub question, Q is not allowed in the sample space. Without Q, you have to write here 10, Jack, King and Ace. So how many cards you have here total? 4 cards. So let me read the sub question in this here. If queen is drawn and put aside, what is the probability that the second card picked up? First card already picked and thrown aside. Now the chance come to your second card. Is an ace. How many ace cards you have here? I have only one. So let the event be E2. E2 is equal to, I will write in the flower bracket A. N of E2 is equal to 1. What is the probability of occurring this event? P of E2 is equal to N of E2 by N of S. That is equal to 1 by 4. Coming to one more sub question in this. What is that sub question? That the second card picked up is a queen. Can you see any queen card in this? No. Already we have taken the queen and thrown aside. So there is no Q card in this. So what happens here? That event is not possible. So when we are unable to do the event in a probability, we say that the event is impossible, and that is called as an impossible event. If you want to write value is 0. So you can write the event is impossible. Thank you.